this lesson we'll be looking at aromaticity, Huckel's rule. But before we continue, let's look at the concept of conjugation, an easy way to understand it. Number one, if you have a compound where a double bond is followed by a single bond and a double bond, it is a conjugated compound. 2, if a double bond is followed by a single bond and a positive charge, it is a conjugated compound. 3, if a double bond is followed by a single bond and a negative charge, it is a conjugated compound. 4, if a double bond is followed by a single bond and a lone pair, it is a conjugated compound. Now, looking at these compounds, looking at these various compounds, let's see which of them is conjugated and which is not conjugated. In the first case, we have a double bond followed by a single bond and a double bond. So we'll write 1, 2, 3. And that is an example of this type of conjugation. So it is a conjugated compound. Now, in the second compound, we have a double bond followed by a single bond and a positive charge. So we'll write 1, 2, 3. And we'll say it is a conjugated compound. And that is the example. Now, in the third case, we have a double bond followed by a single bond and another single bond. So it is not a conjugated compound. In the next case, we have a double bond followed by a single bond and a lone pair. And we'll write 1, 2, 3. And this is a conjugated compound. In this case, we also have a double bond followed by a single bond and a lone pair. And that too is a conjugated compound. And this, the example is example number 4. So these are the different examples of the type of conjugated compounds that we have. Now let's look at some aromatic compounds and Huckel's rule. What are the properties that make a substance aromatic? We have 1, the compound must be cyclic. 2, it must be planar, that is sp2 hybridized. 3, it must be conjugated. And 4, it must follow Huckel's rule, who say that it must have 4n plus 2 pi electron, where n can be any positive integer from 0, ranging from 0, 1, 2, 3, 4, 5, 6, and like that. So n is just any number. So Huckel's rule say that if you have 4n plus 2 pi electrons, then you are what? An aromatic number. So where n is equals to 0, 4n plus 2 will be equals to 4 into 0 plus 2 n is equals to 2. When n is equals to 1, 4n plus 2 will be equals to 4 into 1 plus 2 n is equals to 6. When n is equals to 2, 4n plus 2 will be equals to 4 into 2 plus 2 and is equals to 10. When n is equals to 3, 4n plus 2 will be equals to 4 into 3 plus 2 and is equals to 14. When n is equals to 4, 4n plus 2 will be equals to 4 into 4 plus 2 and is equals to 18. When n is equals to 5, 4n plus 2 will be equals to 4 into 5 plus 2 is equals to 22. When n is equals to 6, 4n plus 2 will be equals to 4 into 6 plus 2 is equals to what? 26. So for pi electrons, for a compound that have pi electrons equals to either 2, 6, 10, 14, 18, 22, 26, has fulfilled a condition for aromaticity. So if you have this number of pi electrons, then and you are cyclic, and you are planar, and you are conjugated, and you follow this number of pi electrons, then you are conjugated. Note, a single pi bond is equals to 2 electrons. Let's look at some examples. Let's look at benzene. From the structure, we see that benzene is cyclic. It is planar because the carbons are sp2 hybridized. The bonds are conjugated. We have a double bond followed by a single bond and a double bond. And we have 3 pi bonds. Remember, a pi bond is equals to 2 electrons, so 3 pi bonds will be equals to 6 pi electrons. So we have 6 electrons, pi electrons. Now, when n is equals to 1, 4n plus 2 will be equals to 4 into 1 plus 2, and to be equals to 6. And since the pi electron is equals to Huckel's number of pi electrons, benzene will be said to be what? Aromatic. It is cyclic, planar, conjugated, and has 6 electrons, so it is aromatic. Let's look at another example. Naphthalene. Naphthalene is cyclic. That is one condition for aromaticity. It is planar because all the carbons are sp2 hybridized. And then the bonds are conjugated. A double bond followed by a single bond and a double bond. And we have the total pi bonds are equals to 5. That is the 5 double bonds there. And that means that the number of pi electrons is equals to 10. 5 times 2 will give you 10. Now from Huckel's rule, 4n plus 2, if we have n equals to 2, will give you 10. That is 4 into 2 plus will be 10. And since the number of pi electron is equals to Huckel's number of pi electrons, then naphthalene will be said to be what? Aromatic. Let's look at anthracene, another example. Anthracene is cyclic. It is planar. The bonds are conjugated. And total number of pi bonds here is equals to 7. Remember, a pi bond is equals to 2 electrons. So for 7 pi bonds will be equals to 14 pi electrons. Following Huckel's rule of 4n plus 2, if n is equals to 3, now we have 4 into 3 plus 2 will give us 14. So since the number of pi electrons is equals to Huckel's number of pi electrons, we will say that this compound is aromatic because it is cyclic, planar, conjugated, and has the same number of Huckel's number of pi electrons. Let's look at cyclopropanol cation. Cyclopropanol cation is cyclic. It is planar because it's sp2, the carbons are sp2 hybridized, and it's conjugated. We have number of pi electron, pi bond is equals to 1 because we have 1 double bond there. That means the number of pi electron will be equals to what? 2. So if n is equals to 2, 4n plus 2 will be equals to 4 into 0 plus 2. And the 4n plus 2 electron will be what? 2. So number of pi electron is equals to 4n plus 2 pi electron. Therefore, it is aromatic. Let's look at cyclopropanol anion. It is cyclic. The carbon are sp2 hybridized, so it is planar. And the bonds are what? Conjugated. A double bond separated by a single bond and a lone pair. So we have 2 pi bonds and 1 lone pair. Therefore, the total number of electrons will be equal to 0 because a lone pair represents 2 electrons and 2 pi bonds will give you 4 electrons. Therefore, if n is equals to 1, 4n plus 2 will be equals to what? 4 into 1 plus 2, and that will be 6. So number of pi electrons here is also equals to number of what? 4n plus 2 electrons. And the compound will be said to be what? Aromatic. Let's look at cyclobutadiene. It is equally cyclic. The carbons are sp2 hybridized, so it is planar and conjugated. Number of pi bonds is equals to 2. And therefore the number of pi electrons will be equals to what? 2 times 2, and that will be 4. Therefore, 4n plus 2 electrons will be equals to, if n is equals to 0, 4n plus 2 electrons will be equals to 2. If you replace n with 0. So, number more pi electrons is equals to 4n plus 2 pi electrons. And therefore, it is not going to be aromatic. And if you say n is equals to 1, it is still 6. So 6 is not equals to 4. Therefore, the compound is not aromatic. So you see, we have gotten examples of aromatic compounds and non-aromatic compounds. Classwork. Is the compound below an aromatic or a non-aromatic compound? Leave your answer in the comment section, whether it is aromatic or not. Do not forget to subscribe, like, share, and comment.